Network test views and Thousand Eyes give you visibility into how your network performs and connects between agents and target devices. These views help you monitor remote server access, track end-to-end connections with per-hop visibility, identify path changes, verify device availability, and detect network degradation. You can also validate network optimization settings like DSCP and MTU to help ensure your network runs smoothly and efficiently. Let's look at the network test views. To get started, select Network and App Synthetics and go to Views. From the drop-down menu at the top of the page, open the view for your test. In the Views page, you'll see three panels. The top panel contains the test selector and the global filters. The primary panel contains the views list, the metric selector, and the timeline. Lastly, the secondary panel includes the path visualization, the map, a table with detailed metrics, and any dependent applications identified by the test target. Let's look at an example of a network test. In this case, it's an agent-to-server test targeting Microsoft.com. In the top panel, you can see a drop-down menu with the name of the test and the source agents. If you want to view data for a specific agent and target server, use the drop-down menu to select the agent and the target server. Let's start by looking at the primary panel. The available views in a network test include network and routing layers. The network overview shows three main metrics: loss, the percentage of packets lost; latency, the average time it takes for packets to travel between endpoints; and jitter, the variation in latency over time. You can also select multiple metrics in the Metrics menu. Under the Comparison option, choose additional metrics to correlate performance side by side. For example, let's select both loss and latency. Now we can see all three metrics together. Now let's move on to the secondary panel. The path visualization maps the tracer route data between the source agent and the target. This view helps pinpoint potential problem areas across both private and public network infrastructure. With hop-by-hop visibility, you can see exactly how traffic is routed and immediately identify where network issues may be occurring. When you hover over an agent in the path, you'll see detailed information, including the public IP address, network name, location, interface details, and performance metrics such as loss, latency, and jitter. To view link details, hover over a link. In the Path Visualization tab, you can filter specific agents, group them by agents or networks, and highlight forwarding loss and link delay. In the Info section, you can view key details about the path, such as DSCP tag changes. If an MPLS tunnel is detected, this section will include relevant information. The Map tab shows the geographic location of the agents running the test. Each location is color-coded according to performance metrics at the selected time interval. The secondary panel's Table tab displays all the metrics alongside the corresponding agents for the test. The Dependent Applications tab displays data from application performance management tools such as App Dynamics, relevant to the target application. In this example, there is no active integration, so no data is available. Under the routing layer, BGP Route Visualization shows how data travels across the internet. It helps troubleshoot issues that may prevent packets from reaching their destination. This view provides BGP route information from monitors around the world to the target destination. The results are the same whether the test is agent-to-agent or agent-to-server. However, agent-to-agent tests are bidirectional, so both the dataset and the path visualization are available in both directions. And that wraps up our look at network test views. We covered how network testing evaluates performance and connectivity between agents and their target destinations by providing critical information such as packet loss, delay, and latency. The path visualization view gives us hop-by-hop insights into how data travels, while the BGP visualization adds context from global monitors to detect routing issues. By combining these perspectives, we gain a complete understanding of network performance between the source and the target. Thanks for watching.